My dear NEET warriors, welcome to the next session of units and dimensions. In the previous session, we have already seen what is unit, what is a physical quantity, what are the different types of physical quantities, like the fundamental seven quantities like mass, length, time, current, temperature, amount of substance, and luminous intensity, and the two auxiliary units like solid angle and plane angle, and everything else like force, momentum, field, everything else is dependent on these fundamental quantities. We saw the different system of units, and we also saw what are dimensions, and we saw that auxiliary quantities like angles, they have units but they are dimensionless. So it is quite possible for physical quantities to not have dimensions at all. So all these things done in the previous session. Today we are going to progress with the dimensional analysis and the significant figures part. With me, your captain Shreyas. If you have not yet liked the session, mark your attendance right away right now. And if you have missed the previous class, please watch it or right over here. You can see it's here. Yeah, the units and dimensions part. So please check it out and make sure you're subscribed onto the channel. Okay. Good evening, Himan. Uh, Himmat, welcome Charan. Hi Govarshan. Hi Varshita. I want to become an oncologist. Wow, this dream. I get to hear from quite a few, and I'm really proud that you guys are already having these ambitions. And just a few days back, I was interviewing all our NEET 2025, pass outs, and they had done extremely well in their NEET 2025 examination. And they too were, some of them told oncologists, some of them told they want to be neurosurgeons, some of them told they want to completely go into research field. So kudos guys, and keep checking out the description box after the session is over so that you will get the PDF. Homework answer is also there in that, but everybody should put up the homework answer in the comments to show your consistency, to show your attendance, to show your seriousness. Very good. Sai and Shalu and Hemavarshini and Aruna, Ambika, Sudarshan, Harshini, and the sorry, Threat. Oh my God, this is such a big name. Sorry, boss. I cannot pronounce such a big name, but kudos. Yeah, and you can call me Sharma. Thank you so much. After such a big name, you told me you can just call me Sharma. Very nice. And we have Madhu and Satyadi, Darshini, Naiza, and Krishna. Very good. Kudos, guys. Keep answering the questions. Next lecture, I'll show you today's session homework answers along with the names. Right? Good evening, Mahesh. And hi, Sharma. Welcome, welcome, Saka. Hello, Shamla. Hello, hello. Good evening. So let's begin with the class. Let's begin with the class. And today we are going to start off with the concept of, the usage of dimensional analysis. By the way, if you have not yet checked the result videos, you should please check it out. You can see Rishit, Avigyan, Soham, so many of them. And in fact, many of the toppers and, even Daksh and all of them being felicitated in our validatory function. And these students have made us extremely proud. So even my interview with Daksh and so many others are already there. These are the J results. Even we have Vedant who did extremely well in NEET exam. He got 625 marks. So that interview also will be coming up very soon. Okay. So all the toppers being felicitated, the interviews, everything are slowly getting uploaded on the channel. Please check it out. You will derive a lot of motivation and see how they exactly think. And it is not that they are very nerdy or geeky, but in fact they are so pro and good at so many other things, and it's not like they study 15 hours a day or 12 hours a day. So you should learn the strategies and develop your skills also in the same manner. Okay, I'm pretty sure within 1 or 2 years you two all will be over here, right? So we talked about what are dimensions in the previous session, and we noted some of the dimensions of certain physical quantities. Like for example, say you have acceleration, the dimension of acceleration. Well, if you remember the unit, it is more than sufficient to recollect the dimension. Meters per second square. Meter is nothing but measuring the length, so length raised to 1, and per second square, so the power of time will be -2 second square, so raised to 2, and because it is divided by, so you put negative power. Same way, if you ask me what is the dimension of just velocity, remember the unit, you will automatically get it. It is meters per second. So length raised to 1, time raised to -1. If you ask me for density, remember it was mass by volume. Mass is m raised to 1 by volume. So negative power of length raised to -3, because volume is length into breadth into height. So 3 times length. So length raised to 3. But since it is in the denominator, you put negative power to bring it on the top, right? So these are some of the examples of dimensions of some physical quantities, which we have seen in the previous session. Now let's talk about the application part. Where do you see, where do you use it, etc. There are three main uses. First one is the dimensional homogeneity and the consistency part. This application will help you in an objective exam like NEET, where you have 4 options, to either eliminate or select few options using this trick. So this is a very cool principle which will help you either eliminate or to select some of the options in some questions, not all the questions. So how does it do that? So first of all, it says that whenever you have physical quantities, let's say some physical quantity 1 and then some physical quantity 2 and let's say some physical quantity 3, then you can add them and subtract them or whatever, only if the dimensions of the physical quantity 1, the dimensions of that physical quantity number 2, and the dimensions of physical quantity number 3, they are the same. If the dimensions are same, only then I can add them, else I am not even permitted to add or subtract them. So the first thing is all about we can only add, we can only add or subtract similar dimensions. We can only add or subtract similar dimensions. Best example for this, say for example, force 1 minus force 2 minus force 3 plus force number 4 versus force 1 plus acceleration 2 minus mass number 3 versus, imagine something like this, velocity 1 minus acceleration 2 plus let's say density number 3. Out of these, as you can see, my dear students, only this makes sense because everything is force, they all have the same dimensions, so this is perfectly fine. But if you see force, acceleration and mass, three different things. How can we add force with acceleration or subtract acceleration with mass? This is definitely not right. Even adding velocity to acceleration or subtracting that with the density or anything, guys, that is also not permitted because the dimensions are different. So this is what dimensional consistency or homogeneity is all about. Homo means same, homogeneity means same dimensions, dimensions wise. Okay, consistency means the same dimensions, it is consistent, this all are same dimensions, only then it is permitted or else it is not allowed. Is this absolutely clear, my dear students? Oh, awesome, Balaji, it's your first class. But if you have not understood what is dimensions, I would request you to check out the previous session, because we are doing lecture by lecture. We are not doing one shots, okay, marathons, because that is completely meaningless. The whole community of YouTube who was right now, who's still doing, marathons or thing, guys, it's not going to work out. You need to be consistent, do small bits and pieces, but do it in detail, because in marathons, what happens, the first 3 hours or 2 hours are very good, then the speed becomes very fast, the depth is very less, the concentration goes down, and you miss out all the topics after 1-2 hours, so no point. All right, the next important thing in the dimensional homogeneity and consistency is that it's okay to multiply and divide any dimension with any dimension. So physical quantity 1 multiply with physical quantity number 2 divided by physical quantity number 3. The dimensions may or may not be the same. That is perfectly fine. So multiplication, for multiplication or for division, for multiplication or for division, the dimensions can be different. The dimensions can be different, can be different. And you will use your regular rules. Like for example, say, I tell you, length raised to 1, t raised to minus 1, the whole thing into t raised to 2, the whole thing divided by m raised to 2. Okay, something like this. You can just do your normal multiplication, guys. M is in the denominator. If you bring it on the top, m's power will be negative 2. Length is not there anywhere, so length raised to 1. Here plus 2 and minus 1. Minus 1 plus 2 is nothing but plus 1. So t raised to 1. So you just do your normal multiplication and division like you do normally. There is nothing wrong in that. Similarly, another example, let's say, L cube, and let's say we have t raised to minus 1 and t raised to minus 1 over here, and then we have m raised to 1, L raised to 1, and this whole thing divided by L, and let's say we have over here t raised to minus 2, something like this. Guys, again do the normal multiplication or division. That's it. As you can see over here, well, few things like this L and this L will get cancelled. Okay, this t raised to minus 2, I can just bring it on the top. So let's see what happens now. Mass wise, there is only one mass. So m raised to 1. Length wise, there is L cube over here. This one L cube. T raised to minus 1 is there. And this minus 2 will become plus 2. So what will this become? It will just become m raised to 1, L raised to 3, minus 1 plus 2 is plus 1. So that's it. M raised to 1, L cube, T raised to 1. So normal multiplication and division of dimensions is fine, even though they are of different dimensions. Okay. Only while adding or subtracting, you need to be careful, because I can't add 2 apples minus 3 oranges is equal to how many apples? You'll be like, what? Apples and oranges? How can I subtract or add? Okay, so it is not making sense. But while multiplication, it is fine, like 5 oranges into 10 rupees. So I will get, okay, so what is the total cost? That's perfectly fine for multiplication and division. Good evening, Faith. Clear. Lalurze, very good. Awesome. Sir, vernier caliper and screw gauge, not in this class, in another class. Okay, it's a separate lecture in itself. Another important thing is that always, if you have some equation and if you put equal to, the dimensions on the left hand side and the dimensions on the right hand side will always have to match. The dimensions on the left hand side and the RHS will always have to match, or else it will be said to be inconsistent. So this is said to be a consistent equation. This is said to be which kind of consistent? Dimensionally consistent. This is dimensionally consistent equation. Example, if I tell you velocity, or let's say distance, is speed multiplied by time. If you check over here, LHS, the dimension is L raised to 1. On the RHS, if you see, it is L raised to 1, T raised to minus 1. And this time has just T raised to 1 over here. Just T raised to 1 over here. Minus 1 and plus 1 will cancel. L raised to 1 will remain. So definitely I can put equal to. So 100%, this is dimensionally consistent. This is dimensionally consistent. Nothing wrong with it. If I give you another example over here, say this distance is 7 times of Vt. Here also left hand side the dimension is of length. Right hand side also the dimension, if you calculate, it is still of length only, because plus 1 and minus 1 will cancel. So this is also dimensionally consistent. But there is a catch. Even though dimensionally they are satisfying, LHS is equal to RHS, there is a catch. Can you guys quickly tell me what is that catch? If you remember this formula for distance is speed into time. Where is distance 7 times speed into time? This is physically wrong. Physics wise, formula wise, this is wrong. So just because it is dimensionally correct does not mean it is actually physics wise, chemistry wise, mathematics wise correct, science wise correct. Okay, so this particular thing, okay, distance is speed into time, is physics wise absolutely correct, but physics wise 100%, mathematically this is wrong. Okay, so just because it is dimensionally consistent does not mean it is actually correct. It may be correct, it may not be correct. Is this entering your head, my dear students? Hi Pecky, welcome back. Hi Manoj, मैं क्लास 10 क्या नीट का प्रिपरेशन कर सकता हूँ? Yes, Ariba, definitely you can start. Many of the students started their NEET basically foundation journeys back in 9th or 10th standard. Start with the 11th standard syllabus. Don't do the 12th standard syllabus. Just watch the 11th standard classes. Take your time. Take your entire maybe time till October or September to do at least the mechanics part of 11th standard. That would be a good start for your NEET preparation in physics terms. Okay, right, everyone? Okay, but imagine if it so happens the dimensions of LHS is not equal to the dimensions of RHS, then it is said to be dimensionally inconsistent. Dimensionally inconsistent. And good example of that, a good example of dimensionally inconsistent equations. Imagine distance is speed square multiplied by time, or speed multiplied by time cube. This is dimensionally going to be wrong because distance has the unit of length, speed has the unit of length raised to 1, t raised to minus 1, time cube means t raised to 3. Obviously, LHS is not matching the dimension of RHS. So if this is the scenario, this is dimensionally inconsistent, and once it is dimensionally inconsistent, then physics-wise 100%, it is wrong. Nowhere it is even possible distance is speed into time cube. So keep this in mind. If it is dimensionally correct, then it may be physically correct. But if it is dimensionally wrong, it is going to be physically wrong. Okay? Shall I write it down as a rule for you? So if an equation is dimensionally correct, then it may or may not be physics or maths wise, or basically science wise, it may or may not be correct. It may or may not be physics or mathematically correct. But if an equation is dimensionally wrong, then it is physically or mathematically incorrect. 100%. It is definitely incorrect physically or mathematically. Give me a fire emoji and quickly smash that like button in case you haven't done that yet. Yeah, everyone? Great. Awesome. All right. There is no easiest way to remember dimension apart from remembering the units. So if you remember, kg meter per second square is the unit of force. So kg is mass, meter is length, and per second square, that means time raised to -2. So if you know the units, it is easier. Number one. Number two, if you know the formula, then from the formula you can derive the dimensions. So as you progress, you will learn formulas, be it gravitational field, be it flux or whatever. So when you know the formulas, you can easily get those dimensions also. So either units or the physics formula. Is that absolutely clear? All right, Manoj, perfecto. Awesome, awesome. Great. Last one. Last one over here. Last one over here. Imagine uh, quantities like trigonometry, logarithm, exponential, etc. They are always going to be dimensionless. So say for example, we have a quantity like sine of something, cos of something, or tan of something. Then please remember, whatever is there inside of this, it is always going to be dimensionless. Not just that, even the dimension of this entire thing is nothing. So basically, whatever is there inside is angle, and angle is a dimensionless quantity, right? This is basically angle. Angle has no dimensions. Even the trigonometric value has no dimensions. So they are all dimensionless. They are all dimensionless. Not just that, even this e raised to something, e raised to something, whatever is there inside is also dimensionless, and this quantity itself, okay, this quantity itself is also dimensionless. This is also dimensionless. Not just that, even the quantities of logarithm, which you are going to study very soon. So log of something. So if you take the log of some quantity, you are going to see that it is also going to be dimensionless. So all these quantities, trigonometric, exponential, logarithmic, they are all going to be dimensionless, and whatever is there inside their brackets are also going to be dimensionless entities. So even this over here is dimensionless entity. Is this absolutely clear, my dear students? All the things inside the brackets are also dimensionless. They are all dimensionless. Very, very important. Very, very important. So say for example, I tell you, for example's sake, x is equal to a into sine of something like omega into t. X is a into sine of omega into t. X happens to be the position. X happens to be the position. T happens to be the time. If I ask you, can you figure out the dimension of A, and can you also figure out the dimension of omega? Can you find out the dimension of A as well as omega? How will I approach this question? Let's think one by one. First of all, whatever trigonometric quantities are there, whatever is there inside of it is an angle, so that should be dimensionless. So 100%, whatever omega t is, that should be dimensionless. So it should be dimension of omega into dimension of time, that means t raised to 1 is dimensionless. So therefore, omega will be, if you take it on the other side, it will just become t raised to minus 1, and even if this is there, it doesn't make sense to multiply this with nothing. It is just going to be t raised to minus 1 only. So the dimension of omega is time raised to negative power 1. Very good. Similarly, we all know that sine of anything, that quantity itself is dimensionless. So this is as good as saying this is dimension of x is equal to dimension of a multiplied by dimension of sine of whatever omega t is. We know sine itself is a dimensionless thing. X is position means length, so length raised to 1, and this is nothing but a. Therefore, the dimension of a will be nothing but the dimension of length itself. This is nothing, so no dimensions are there, so forget it. So dimension of a is the dimension of length raised to 1 itself. Is this absolutely clear, my dear warriors? Okay, dimensions is not there. How we want to solve the problem? I'm not really sure, Manoj, what exactly you mean. Dimensions are not there means, if this is the kind of question that I'm talking about. See, sine did not have dimensions. Whatever is there inside did not have dimensions. So that is exactly what I'm talking about. Okay, we will do more questions. I think we have Yeah, let's do one more question on this so that you guys get an idea of it. Imagine another example. Imagine another example. This is some quantity A which is equal to B divided by C uh, into e raised to C divided by T square into M. Okay, C into T square into M. Chumma something I have put. Okay, so from this, can we figure out the dimension of C? T is time. This T over here is basically time. This M over here is basically mass. Can we figure out the dimension of C? And if it is already told to me that over here, let's say for example, this is, let's say, length. So if this is length, can you also figure out the dimension of B? Can you also figure out the dimension of B? And from this also figure out the dimension of C? I think we can. Whatever E's power will be, the power of E is always dimensionless. The power of E, exponent, is always dimensionless. I just told you, E raised to anything is the exponent. Okay, so whatever this is, basically C divided by T square M, this should be completely dimensionless. Therefore, the dimension of C should be nothing but T square M's dimension if I take this over here. So the dimension of C will be mass raised to 1 time raised to 2. That is the answer. So the dimension of C is mass raised to 1 time raised to the power 2. Okay, next important thing, left hand side we have length. Okay, so the dimension of length should be equal to this thing, which is the dimension of B by C, and the dimension of this whole thing will be nothing, guys, because E raised to anything is dimensionless, right? So this whole thing over here, E raised to some number, is a completely dimensionless entity. So I have put over here nothing. So this is exponents. Exponents are dimensionless. Are dimensionless. Dimensionless. Okay. So length means L raised to 1. B is on the top, so let me just put B as it is. C, I already figured it out. It was M raised to 1, T raised to 2. This was nothing, so forget it. Shift it on to the other side. So the dimensions of B will be M raised to 1, T raised to 2 multiplied by L raised to 1. So therefore, the dimension of B will be M raised to 1, L raised to 1, T raised to 2. So I have figured out the dimension of B as well. So this is how you can use the dimensional consistency or homogeneity principle to figure out any unknown dimensions, if at all, or to check if it is perfect or not, like this particular thing. You can see if some option, if some equation is dimensionally wrong. So if some option is dimensionally wrong, it can't be correct. It has to be incorrect. So we'll eliminate that option. Imagine some option says, option C says D is equal to VT cube. It is impossible for that to be correct. So you will eliminate such an option. You will eliminate such an option. Is that making sense, everyone? Clear? Awesome. Clear. Perfecto. Let's go, guys, to a question coming up on your screen. If velocity of a particle is given by at plus b by t plus c, where a, b, c are some constants, the dimensions of a, b, and c are. Come on, guys, let's start doing it one by one. What are the dimensions of a, b, and c? Focus your attention, guys, quickly on this number t plus c. You can only add and subtract quantities of the same dimension. So while adding, the dimensions should be the same. The dimensions should be the same. So the dimension of T should be the dimension of C. Therefore, the dimension of C is nothing but T raised to 1. So the dimension of C is T raised to 1. So this is first thing, and I can only see option A, which says that the dimension of C is T. Rest all are giving something else. Even if I don't solve it for A and B, without even looking, I should be able to mark option A as the right answer. Do you understand that? By chance, this is by luck. But let's say C is T is there in 2 or 3 options, then I have no other choice but to solve it properly. And as a teacher, as a class, we should actually solve it properly, not just eliminate. So this is what I mean by elimination. Okay. All right. Next, over here, V and AT should have the same dimensions, and that should also have the same dimension as this. So if you see this quantity and this quantity, right, the dimension of velocity should be the same as the dimension of A into T. Velocity has a dimension of length per unit time. Okay, this is A, which I do not know right now, and this is T. T will be nothing but T raised to 1. If I bring it onto this side, the dimension of A will become L raised to 1, T raised to minus 1. This will also come over here, it will become T raised to minus 1. Okay, this 1 will become negative 1 over here. So the dimension of A, will become L raised to 1, T raised to minus 2. Exactly what we want. L raised to 1, T raised to minus 2 is the dimensional formula for A. Last thing over here, whatever is the dimension of velocity should be the dimension of this entire thing over here. Entire thing over here. So the dimension of velocity, because added and subtracted with the same dimensions, so will be the dimension of B divided by T plus C. Now velocity has a dimension of length raised to 1, T raised to minus 1. On the top I have dimension of B. Below, time and C, they have the same dimensions. Technically it is the dimension of time. So if I bring it over here, it will just become L raised to 1, T raised to minus 1, and this on the top will become T raised to 1 is nothing but the dimension of B. What will this be? This will just be L raised to 1. Minus 1 and plus 1 will be 0. So that is the dimensional formula for B. So dimensional formula for B is just L. Exactly what we wanted. So that is why the answer is A. Is that obvious now? Clear? Understood? How to solve these questions of dimensional consistency? Everybody? Perfecto? Amazingo? Great. This type of question was also asked in your NEET re-examination last year. And you can see now it is not that difficult to solve this as well. The previous year NEET question. Okay, let's try this. This was for potential energy of a particle. Okay, some ax square plus root x plus b something and all is given. Question is find the dimensions of a square by b. How do you do it? First of all, let me calculate on the sidelines. What is the dimensional formula for energy? What is the dimensional formula for energy? The dimensional formula for energy, if I know the formula, for work, I am done because work and energy, same unit, same dimension. Work is force multiplied by displacement. Force, I know it is mass into acceleration. Acceleration is length raised to 1, T raised to minus 2. Displacement is nothing but length. So this will just become M raised to 1, L raised to 2, and T raised to minus 2. So that is the dimensional formula for V. Okay, we'll keep this aside. Now, how about this? See, this is root x, right? Root x, my dear students, root of x is added to b. So they should have the same dimensions. So root of x, if it is added to b, it should have the same dimensional formula as b. So what is x? X is position. So it is root of length basically. Root of length is the dimension of b. But what is root of any number? What is a root of any number? It is that quantity raised to the power half. It is the quantity raised to the power half. Okay, so B's dimension I already know now. Only dimension of A is remaining. So look over here carefully. On the left hand side, the dimension of potential energy is there. Right hand side, we have dimensions of A and dimensions of x square. And at the bottom, we have this, which is root of x plus b. Root of x plus b basically. Well, dimensional formula for potential energy is this guy, 1, 2 and minus 2. So I am going to put m raised to 1, L raised to 2, T raised to minus 2 is equal to dimension of A, I do not know. Dimension of X, which is dimension of length, it will be L raised to 2. The whole thing divided by root X, root B, root X and B, they have the same dimensions, which is L raised to basically half. L raised to basically half. Shift it on the other side. So the dimensional formula for A will be, it will be nothing but, check this out, m raised to 1, L raised to 2, T raised to minus 2. Okay, L raised to half will go on the top, and I will be dividing this with, I'll be dividing this whole thing with L raised to 2, because this L raised to 2 will go below. L raised to 2 will cancel, so it will just become m raised to 1, L raised to half and T raised to minus 2. So that is the dimensional formula for A. Now the last thing, you have to find A square by B. So A square by B's dimension will be, square this, so it will be m raised to 1, L raised to half, T raised to minus 2 the square, the whole thing divided by B's dimension, which is basically just L raised to half, my dear warriors. So now it becomes obvious what it should be. M raised to 1 raised to 2, that will be m raised to 2, half raised to 2, it is just 1, so L raised to 1. This will be T raised to minus 4, and below we will have nothing but L raised to half. L raised to half, which we can take it on the top, as L raised to minus half. So 1 minus half is half. So it will become m raised to 2, L raised to half, T raised to minus 4. So that is the answer for this particular question. M raised to 2, L raised to half, T raised to minus 4. Is that absolutely clear? We just got it. Yeah, option number C. Yeah, m raised to 2, L raised to half, T raised to minus 4. So quite a lengthy problem. And imagine, you think in your mind that I have to complete it in 1 minute. It is not possible. Even for a top scorer, guys, even if you are in top 10,000, 5,000, students will not be able to complete it in 1 minute, because writing this only will take time. So keep this in mind in the actual exam also, or even when you are giving class test, or even when you are practicing. Don't pressurize yourself so much that, sir, I took more than 1 minute, how will I do it in the exam? 100% there will be questions which will be lengthy. Some questions will be very straightforward. There will be sections where you have to save time. So if you save time, you will get time for those questions which need time. Getting my point, everyone? Awesome. Great. So that was your NEET question. Going to the next one coming up on your screen, that is conversion of units. Often this is needed, guys. Whenever you want to convert units, you will need it. So say for example, you want to convert from SI system to CGS, CGS to something else. So when you want to do that conversion, you will use this method. So for this, I'll tell you one simple way. If you should know, you should know the dimensions of the physical quantity whose units need to be converted. 100% you will need that for sure. Second thing, you should know all the fundamental units conversion. Only then you will be able to do the complete conversion of units from one complete system to another system. So it goes something like this, where if you have the magnitude n1 in some unit u1, then the magnitude will be something else. Let's say n2 in some another unit, but physically they are the same. Examples of them, just take some examples of them. If I tell you 1 meter, 1 is the number or the value, unit is meter, that is 100% 10 centimeters. U2 is centimeters, N2 is the new value. In some new unit, it will be some new value because the unit is different, but it is the same thing at the end of the day. Or let's say, for example, I say 1 feet is nothing but 12 inches. 12 inches, right? Or let's say I give you, maybe something like, 1 hour, it's a new unit, is nothing but, see, each hour will have, 60 minutes and each minute will have 60 seconds. So this will be 3600 seconds. So all these are conversions at the end of the day. Everybody getting it? Similarly, 1 kg will be nothing but 1000 grams. 1000 grams. So in one unit, the magnitude will be something. In another unit, the magnitude will be different. So this is what the conversion of units says, this formula. N1 U1 will be N2 U2. Now, how do you practically perform this conversion? Let me demonstrate this to you by some practical examples. Say, the best example, I want to convert kilometer per hour into meters per second. Meters per second. 1 kilometer per hour is how many meters per second? I want to do that. Very famous conversion, right? How do you do it? First of all, do you know the dimensions of velocity? This is basically velocity conversion we are talking about. Yes, I do know the formula for velocity. It is length raised to 1, t raised to minus 1. Okay. So here is what I will do. Here is what I will do. Start off by saying 1 kilometer per hour. I want to know how many meters per second it is, right? We want to know how many meters per second it is. So 1 kilometer per hour. Kilometer is for length, per hour is for t raised to minus 1. So you can see dimensions are needed because now I'm going to play with that. I will write it as 1 kilometer because length is raised to 1. So kilometer is the unit of length per unit time. So 1 hour over here, and it is below because the dimension of time is below. So I'm writing this particular unit in its fundamental units with suitable powers looking at the dimension. Oh, kilometer is for length raised to 1. Hour is also time, but it is in the denominator because negative power. Now, once you reach this step, like I said over here, you need to know the fundamental units conversion. So length, fundamental unit kilometer, okay. How many meters will it be? How many meters will it be? 1 kilometer will be 1000 meters, okay. 1 hour for the time unit will be how many seconds? It will be nothing but 3600 seconds. Okay, fair enough. This 0, this 0, this 0, this 0 went. 10 goes by 2 5 times, 36 go by 2 18 times. So therefore, I'll be left with nothing but 5 by 18. This is nothing but meters per second. That's it. So 100%, 1 kilometer per hour is 5 by 18 meters per second. That's it. I have got it. Yes. Did you understand? So if it was something else, let's say it was maybe, 72 kilometers per hour. 72 kilometers per hour. So that number 72 will come into 5 by 18 meters per second. So you can see 72 goes with 18. 4 times 18 4s are 72, 4 5s are 20, 4 5s are 20. So that will be 20 meters per second. So you can easily do that conversion. 1 kilometer per hour is 5 by 18 meters per second. So 72 kilometers per hour will be 72 times 5 by 18 meters per second. So you can do the math and you can get the answer. So this is how conversions can be done. Is that absolutely clear? Okay. The red is kind of not visible on the board. Can you please avoid? Okay, fine, Peggy. Awesome. Okay, I'll try not using it, or I will keep the pen thickness same because I'm just using it for cancelling purposes, not for you to see it so much, but mainly maybe in the notes it will be seen what I have done. This is just for me because I don't want these things to be visible so much actually, because just for my head, when I'm doing the calculations, I'm doing it over here. Okay. Anyways, let's do another conversion. Another conversion over here. Let's do conversion. Let's say I want to convert, let's say I want to convert work from SI system into CGS system. From SI system to CGS system, I want to convert work. Okay, let's do it. First of all, what do I need? I will need the dimensional formula for work. What is the dimensional formula for work? I think we have done it just before. Mass into acceleration is force. Force into displacement is work. So m L raised to 2 T raised to minus 2. I think sometime back we just did it for work or energy. We just did it over here. Yeah, energy, work. That is m1 L2 T raised to minus 2. It's not like I remember it, but when you use it so many times, it kind of gets stuck in your head. So initially, if you're new to the chapter, you might feel a bit uncomfortable in remembering it, but don't worry, everybody feels the same. With the time, you will remember it. Okay, it's not like you will make a conscious effort, subconsciously only you will start realizing how to, just it just comes naturally after some time. Okay, fair enough. Now, once I know this, start off by writing one SI unit of work. One SI unit of work. What is one SI unit of work? Look at the fundamental quantities. Mass, fundamental unit in SI is nothing but kilogram. So it is 1 kg multiplied by, it is raised to 1. Length, it is 1 meter, but length is raised to 2. That is why dimensions are needed. Time, well, time is below. Okay, and it is nothing but 1 second is the unit of time. 1 second is the unit SI unit of time, and it is also raised to 2. So 1 kg into 1 meter square into 1 second square. That is your SI unit of work. But don't stop there. How much is a kilogram? It is nothing but 1000 grams. That's what I was telling you. You should know the fundamental conversions, fundamental units conversions. So kilogram fundamental unit converted into grams, which is CGS. 1 meter is basically 1000 meters, but square it. Whole thing divided by 1 second will remain 1 second even in CGS. Don't worry about it. So this will be nothing but 10 to the power 3. This is power 3, right? And raised to 2. So this will become nothing but how much? This will become 10 to the power 10 to the power. Yes, come on, my dear warriors. This will just become nothing but, sorry, this was centimeters. I had to do, I'm so sorry. I wrote something weird. That's what I was wondering. So sorry, guys. I'll just correct myself. I wrote 1 meter as 1000 meters. I was thinking of kilometers and I wrote meters. My bad. So 1 kilogram is 1000 grams. 1 kilogram is 1000 grams. 1 meter in CGS, centimeters. It will be 100 centimeters. Square it because this is squared. And below we have time. Just keep second as second only. Don't do anything with it. Because even in CGS, time is measured in second. Even in SI system, time is measured in second only. Okay. So 1000 is 10 to the power 3. This will be gram. This is 100 raised to 2, which is 10 raised to 4. 10 raised to 4 centimeter square. Whole thing divided by second square, which is as good as saying 10 raised to 7. 4 plus 3 is 7 gram centimeter square per second square. Now, what is this gram centimeter square per second square? Gram is the unit of mass, length centimeter, time second. This is nothing but the CGS unit. Exactly. So this is 10 to the power CGS unit of work. CGS unit of work. Done and dusted. So 1 SI unit of work is 10 raised to power 7 CGS unit of work. Actually, it so happens the SI unit of work is called joule. So 1 joule, which is the SI unit, is 10 to the power CGS unit of work is called as an erg. So it is 10 raised to 7 ergs. Is that clear, everyone? Yes, Sharma, I just covered it. Yes, perfecto. So dimensions can be used to convert one system of units to another system of units. Always know the units. Write the physical quantity in terms of those fundamental units. Convert each fundamental separately. You will get the new system of units and some number, which is the factor of conversion. That's it. Your job is done and dusted. Is that clear? Very straightforward. Okay, so this is done. Now, the last application, which is dimensional analysis for formulas. Imagine a scenario where you don't know the laws of physics or maths or chemistry, whatever, but yet there is a very, I would say crude way of figuring out or guessing the formula. I do not know how a pendulum works, but I want to know the time period. I do not know what is thrust force, but I still know what it depends on. So I can figure out or guess the approximate formula. This is the third application. So the dimensional analysis for formulas is mainly like a guess to get an approximate formula for most of the times. So you should know what is our physical quantity, what is it basically dependent on it, what is it dependent on. You should know that. If you do not know it, then you cannot use this method. Second important thing is that the constant of proportionality, if any, constant of proportionality, if any, should be dimensionless. Should be dimensionless to use this. Should be dimensionless. This is another important thing. So this was the first thing. You should know what is it dependent on. Don't worry, when we solve the question, you will get it. The last thing is you can't use if the formula has even one plus, minus, trigonometry, or logarithm, or even exponents. Any of these things, we cannot use it. Like for example, imagine if there is one formula f is equal to f1 plus f2 minus f3, how would I know how many terms are there? Because even if I add one f4, still dimensionally it is correct only. If I add one more f5 negative, still it is dimensionally correct. So I cannot guess how many addition and subtractive terms are there while using dimensions, because dimensions does not care no matter how many plus and minuses are there. As long as the dimensions match, we can add them or subtract them. So there is no way to guess just knowing the dimensions. Oh, can you tell how many terms were there? Not possible. Trigonometry, logarithm, they don't have dimensions only. We just saw it some time back that trigonometric functions, logarithmic functions, etc., they do not have any kind of dimensions. They are dimensionless. So we can't use the method of dimensions on something which does not possess only dimensions. Okay, so that is one thing. So let me give you an example so that you guys get an idea of it. Okay, you guys will get an idea of it. Imagine, I tell you, let's say, I do not know the formula for kinetic energy. I'm like, what, sir? You don't know? It is half mv. Let's just pretend. Let's just pretend for some time. I do not know the formula for kinetic energy. Okay. So I tell you, hey, listen, I do not know the formula for kinetic energy, but I can tell you one thing. Kinetic energy depends on the mass and the speed, mass, it depends on the mass and the speed. Can you figure out the formula approximately for kinetic energy? Well, the answer is yes. Let's figure out how it is. Okay. First step, observe. Kinetic energy depends on mass and speed. Symbol for kinetic energy K depends on mass, depends on speed, but I do not know how. So I will say kinetic energy is some constant into mass raised to x, velocity raised to y. X, y, c, all are unknowns. C is some constant of proportionality. C is basically your constant of proportionality. There are no more terms in this, I will assume. Okay, and that is the only way when I can use this method to figure out the formula. X and y, I do not know. X and y are assumed. So x and y are assumed. They are basically unknowns. I do not know that. In fact, that's what we are going to do now to find the formula. Now, one thing is clear. If k is c m raised to x v raised to y, 100%, the dimension of k should be, c is dimensionless, so forget it. Remember, constant of proportionality is always going to be dimensionless. It has to be dimensionless, okay? Only then you can use this method. So it will be the dimension of m raised to x and into dimension of v raised to y, because I put an equal to, so LHS and RHS dimensions should match. This is exactly what dimensional consistency is. Dimensional consistency is exactly that. Is that right, guys? It's dimensionally consistent, so LHS and RHS dimension should match. Kinetic energy, it's an energy, so energy has the same dimension as, energy has the same dimension as what? It has the same dimension as work, right? So it's at the end of the day, it's at the end of the day some kind of energy. Energy has the same dimension, energy has the same dimension as that of work, and work I know is force multiplied by displacement. Okay, dimensionally. This is mass, so m is raised to 1, the whole thing raised to x. Velocity, that is length raised to 1 by t raised to minus 1, the whole thing raised to y. Force is m1 l1 t raised to minus 1. Just try to recollect. Force was m1 l1 t raised to minus 2, sorry, and displacement is l raised to 1. So when you multiply both of them, it will become m raised to 1, m raised to 1, l raised to 1 plus 1, which is 2, and this will become t raised to minus 2. Is that right? So force is ml1 t raised to minus 2, mass into acceleration, displacement is length. So when you do that, you will get the dimension of work or energy or kinetic energy, which is the same thing, m1 l2 t raised to minus 2. On the right hand side, what are you getting? M raised to x, L raised to y, and t raised to minus y. Okay. Now stop for a moment and just think. What is your next step going to be? 100% my next step will be compare the powers. Just compare the powers. Here the power of m is 1. Here the power of m is x. So comparing the powers, just if you do comparing the powers, think about it. On the left hand side, the power of m is 1. Here the power of m is x. So therefore, x is equal to 1. On the right hand side, if you just compare the power of length and left hand side and right hand side, length it is 2 and right hand side it is y. So therefore, y is equal to 2. My job is done. X and y were assumed unknowns. I have now made it knowns by just comparing the dimensions. So now resubstituting. So now resubstitute in the original formula. K will be equal to C into m raised to x. X is nothing but 1. V raised to y, which is v raised to 2. Therefore, kinetic energy is C m v square. Only till here we can get it. We can't progress further using the method of dimensions. But we know in reality, actual formula, actual formula, actual formula of kinetic energy is half mv square. So this thing I cannot do by the method of dimensions. The constant can't be determined, but I know how the formula might look like. The actual formula is half mv square, the constant value is half, but you can see very nicely we have predicted the formula. Is this clear? Hi Satvik. Yes. Unit of CGS system have or not, sir, meaning kinetic energy. I'm not really sure what do you mean by that, Manoj. The CGS system, what do you, I didn't really get you. Okay, Ashwita, got it. Asinath, per day, start off by 10 questions. Just if you're 11th standard student, just 10 questions. Slowly make it 15, 20, 25, 30. When you reach 12th standard, you should be solving around 40 questions to 50 questions per day. That is a good amount of practice as long as you're completing the syllabus. Don't solve more than 30, 40, 50 questions. That is good enough practice, but maintain that consistency. I mean, just think about it. If you're in 11th standard, you have around 600, 700 days of preparation worth left. And if you do on an average, I mean, when you near the end, right, the last 4 or 5 months, then you will be solving 200, 300 questions totally. So maybe around 100 questions of physics. So on an average also, if you solve 50 questions and if you take 600 days, actually you have more than 600 days, but Chuma, let's take it as 600 days. So you can see how many questions you will be able to solve. Getting my point? Yeah, it's more than it's like crazy. More than more than 20, 30,000 questions, right? So that is a good number. But you will not reach 20, 30,000. Maybe even if you reach 10, 20,000 or 10,000 also, it's good enough practice. So build that slow consistency, gradually increase it. Start, if you say, sir, 10 questions also not possible, okay, start with 2. We start with 1. Today you do 1, tomorrow you do 2. Within 10 days, you will reach 10. Just 10 days. You just give me 10 days. Within 10 days, you will reach 10 questions. Slowly make it go till, around 30, 40, 50 questions by the time you reach 12th standard. That is also good enough, right? Okay. Sai, yes, I do remember you, my dear. All right. Great. Right. Let's do some question coming up on your screen based on a similar logic. Force, length, and time are assumed to be fundamental units. Then the dimensional formula for mass will be. Okay, crazy. Let's see, how do we do it? So, here, the quantity of mass depends on force, length, and time. Think of it like that. Think of it like that. Okay. So, mass depends on force, length, and time. There is some constant of proportionality, just forget it. Okay. Force power, I don't know. Length power, I don't know. Time power, I don't know. So, Z. Oh my God. So, dimensionally speaking, the dimensions of mass should be the dimension of force raised to x, dimension of length raised to y, and the dimension of time raised to z. Mass is just m raised to 1. That's all. Okay. Force, we just have been doing it, m raised to 1, l raised to 1, t raised to minus 2. Mass into acceleration, the whole thing raised to x. This is just length, so length raised to y. And this is just time, so this is just t raised to z. That's all. Okay. Now, technically speaking, only mass power is there, but length power, I can just deliberately by force write it down as power 0, and times power is 0 because anything raised to 0 is 1. So it doesn't really harm us in any way. So I can just put 0 powers. It's perfectly fine. It will look good for comparison. Here there is nothing apart from this mass. So m raised to 1. This is L raised to x is there. L raised to x. L raised to y is also there. So L raised to x plus y. Here we have t raised to minus 2x. T raised to minus 2x. And here we have z over here. All right. Now I think it's a good time for us to compare the equations. Let's do the comparing the powers. Oh, sorry, I forgot m raised to x. I wrote m raised to 1. My bad. M raised to 1 raised to x is m raised to x. Okay. Now let's compare this with this. Here you have 1, here you have x. So therefore, x is equal to 1. Okay, that job is very easy. Now let's compare this with this. Power of length is 0. Here we have x plus y. Therefore, y is equal to negative x, or you take y on the other side, or you take x on the other side, it will become minus x. So if it is minus x, that means it will be minus 1. So y is minus 1. So second variable also done. Now let's go with the third variable over here. Okay, power of time is 0. On the right hand side, it is minus 2x plus z. So if you take minus 2x here, z will be equal to 2 times of x. But wait a minute, what is x? X is 1. So it will be 2 times of 1. So therefore, z should be equal to 2. So x, y and z, all three have been found. So resubstituting it back, what will m be equal to? M will be some constant into force raised to x. X is nothing but 1. Length raised to y, length raised to minus 1, and time raised to z, that means t raised to 2. So m will be f raised to 1, l raised to minus 1, and t raised to 2, which is exactly your option number A. Not B. Okay, not minus 2, guys. Just see it. It was plus 2. Okay, z was plus 2. If you make a silly mistake, you will get this option. Okay, be very, very, very careful. Okay, it is not negative 2, it is plus 2. Z was plus 2. So z was plus 2, not minus 2. Understood how to solve these kind of questions? Everyone getting confidence now? Yeah, it's just matching the dimensions, powers at the end of the day, assuming the variables, and then resubstituting it back. It's not difficult at all. Can I give you a homework question before we go ahead? Yeah, please put the answer of the homework question where? In the comments. Don't worry, solution will be there in the PDF. So where is the PDF? PDF will be there in the description and in the pinned message of the comments. Both places it will be there. So guys, I want all of you to solve this as your homework question. Okay, homework question. Answer should be there in the comments. I am going to read out all your names next lecture. Okay. Frequency, velocity, density to be fundamental, the dimension of momentum. Okay. So basically, momentum depends on frequency, velocity, and density. Just giving the starting hint. Momentum, symbol is P, depends on frequency, velocity, and density. Frequency raised to x, velocity raised to y, density raised to z. Just do it after this. You can easily do it after this. So the dimension of momentum will be the dimension of frequency, velocity, and density with suitable powers. After this, solve it, you will get the powers x, y, and z. Okay, I have given you the hint also over here. Answer is there on the next slide along with the solutions. Okay, perfect. The 12th physics electric dipole session is not available in the live section. Yes, there is one session which we need to do before that. Potential energy we have done. Have we done potential energy by any chance? I don't remember. Did we do potential energy? Oh, we did. Oh, so the dipole has to be done. Okay, I'll make sure that it will be made live. Don't worry. If there is a issue with the live session, I will make it live. Don't worry, guys. Okay? Yeah. I will follow the proper order. And tell me, my dear students, are you loving this way of detailed teaching, which is not too strenuous on your eyes or your mental health also, and at the same time for grasping also, these 1 to 2 hour classes are beneficial for you rather than taking 7 hours, 5 hours, 6 hours, 12 hours classes, where after 2 hours, sir, everything is going like an airport, sir. takeoff is happening, aeroplanes are taking off, nothing is entering. Some planes are not even landing on my head. Full rocket system only, sir. And sir, after 3 hours, teacher also understood, students not understanding. So teacher also explaining fast. Tuck, 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 tuck. You see many of the sessions. Yeah, and it happens. And we are also humans, no? It's not the fault of the teacher sometimes. Even I get tired. If I'm teaching 8 hours, 10 hours, 12 hours, I'll be also tired. Yeah. So this is very helpful. Very good. Yes, amazing. And I hope you are telling your batchmates also. And as a true doctor, you should be telling this to your batchmates. Attend every day here. Shreyas sir will make you a ranker topper. I don't know how many of you read my Telegram post and my Instagram post. One student just messaged me saying he got all India rank 982 just by watching YouTube classes, and in physics 99.99 percentile. Yeah, just check it out. I'm not lying. Students message me. And this is not just one student, many students before this also have messaged, and I have posted that on Telegram and Instagram everywhere. So my dear warriors, you're in the right hands. Have faith. Within 1-2 years, depending on whether you're in 11th or 12th, you will be making it through. And in physics, I will make sure that your score will be perfect. Even if the paper is hard, I am telling you, you will get 99.99 percentile. And this time's physics paper was the hardest. In spite of that, my students got 99.99 percentile. This is the confidence Shreyas sir has. And this time, I mean, it was a completely unexpected paper. In spite of that, if students get it, when we are expecting the paper to be difficult, there is no way. If you are serious and you are following my teachings, you are following my lectures, you will, it's not possible for you to get a low score. You will get a very good score in physics. That one thing I can guarantee you. Yeah. Great. So let's talk about significant figures. And this will be particularly useful in the next class. You will see that. So today we are just going to learn how to calculate significant figures and how to add, subtract, multiply significant figures. That's all. Okay. So we are learning how to measure the significant figures, rounding off and all of it. Next class we will be applying more of it. You will see. Thank you so much. Manoj, Asinach, Himat Singh, Ashwita. Thank you, Sharma. UV Rao Govarshan. Thank you. Thank you. Thank you. Thank you, Ruby. AL Gaming. Great. So, significant figures are the digits of importance. Like if I write 4.0123, there are some important digits in it. They have some value. If I have written it with some decimal place or whatever, it must carry some value. So, significant means importance, figures means digits. So, they are also called as the digits of importance. Digits of importance. And there are some rules of it. Like you might have seen some, especially chartered accountants or in some places, they write how much amount does this cost, and they say, it costs 0.0725 rupees or dollars. You might have been wondering why 00, because maybe, or even in a petrol pump it shows 0.005 liters. These zeros are not significant. That zero just shows because of the meter or the digital configuration, however it is. So sometimes you might see some zeros here, but they have no value as such. But sometimes these zeros will have value, and when they have value, when they don't have value, that's what we are going to see. Okay, there are a lot of rules for significant figures, and we are going to see all these rules one by one. If you have any non-zero digit and a zero between the non-zeros, then they are significant. Example 523, 5023, 2, 3, 1, 7, 8, 9, 2, 1, 1, 0, 2, 0, 0, 0, 5, 2, 0, 0, 0, 0, 9. In all these things, you will notice one interesting thing. 5, 2, and 3. All are non-zeros. They are all counted as significant. So this has basically three significant figures. 5, 2, and 3 all are non-zero digits. But this 0 is trapped between two non-zeros. So that also becomes significant. So this has four significant digits. 1, 2, 3, 4. All these are non-zeros. 1, 2, 3, 4, 5, 6. All these are non-zeros. So this has six significant digits or six significant figures. That's how you count them. Same way over here, 1, 5, and 2 are non-zero numbers, but the zeros are trapped between them. They are all significant now by this rule. 1, 2, 3, 4, 5, 6, 7. So this has seven significant figures. This and this are non-zeros, but 1, 2, 3, 4, 5. 5 zeros are trapped plus this 2. So this has seven significant figures. Understood how to calculate this? Don't worry, go version. I'm coming to 1000 and everything. Every rule is coming. One by one, I'm explaining you all the rules. Okay. Next rule. Next rule. Next rule. Okay. Just like this rule, the next rule is coming up. The ending zeros or the powers of 10, the ending zeros, this is without any decimals, without any decimal points, or basically the powers of 10, the powers of 10, they are insignificant. Very, very important. The tick mark is for significant, the cross mark is for insignificant. Examples for this. One person said 700, okay, 0, okay, or let's say 520, or let's say 729 multiplied by 10 to the power 7, or 502 into 10 to the power minus 5, or even let's say 20900 into 10 to the power 3. In fact, not just this, even the beginning zeros, even the starting zeros, even the starting zeros, this is again without any decimal place, they are also insignificant. Let's take 007, the bond number, or 08090 into 10 to the power minus 5. In all these things, this 7 is significant, this 52 is significant, this 729 is significant, this 52 and 0 is trapped between two non-significants, between two significants, that also becomes significant. This and this is significant, this is trapped 0, trapped zeros are always significant, this is significant, this 8 and 9 is significant, the trapped 0 is significant. All these other things, these are ending zeros, powers of 10, not significant. Ending zeros, powers of 10, before any first digit, all the starting zeros, insignificant, starting 0, insignificant, ending 0, insignificant, power of 10, insignificant. So guys, over here, we just have one significant digit. Here we have two significant digits. Here we have three significant digits. Here also we have three significant digits. Here we have again three significant digits. Here we have exactly one. And here we have three significant digits. That's how you calculate the significant digits when zeros are ending or zeros are at the beginning or the powers of 10 are there. Is this clear? Yeah. So Himmat Singh, I just mentioned the 0 before the non-zero, the starting zeros. Yeah, these are the zeros before the non-zero. They are also not significant. These are our starting zeros. These are our starting zeros. This zero is also before the non-zero. They are also insignificant, considering no decimal places. With decimal places, some rules are there. We'll just talk about it. Till this point, absolutely clear? Okay. Now comes the trouble of decimal places. Only for decimal places, you need to be little bit careful. So what is it for decimal places? With basically decimal places, with decimal places, the zeros after the decimal, the zeros after the decimal are always going to be significant, but the zeros before the first non-zero, the zeros before the first non-zero, they are not going to be significant. They are not going to be significant. Let me give you examples of this. Let's say 729.000 or 50.0 or 2080.00 or 523.40 or let's say 0.005, 0.02030, 0.000500900 into 10 to the power minus 7. Another number, let's say 290.0030 into 10 to the power 6. Let's take all these examples. You will have no doubt. First of all, let's mark all the non-zeros. Non-zeros, complete non-zeros. They have to be significant. Wherever I see non-zero, they have to be significant, guys. Okay. Everywhere, trapped zeros are going to be significant. Trapped zeros. I can see these zeros are trapped. I can see this zero is trapped. I can see these two zeros are trapped. I can see all these zeros are also getting trapped. Powers of 10, never ever significant. I have already told you. Powers of 10, never ever significant. So forget that. If there are zeros after the decimal, that's it. After the last non-zero, whatever, they are always going to be significant. So the zeros are after the decimal. So 100% by this rule, they will be significant. The zeros are after the decimal. That's it. And if it is trapped zero, automatically it becomes decimal. Any trapped zero between two significants automatically becomes significant. These zeros are significant and this is a trapped zero becomes significant. This zero is after the decimal and after the non-zero. So 100% it will be significant. Is that clear, everyone? But over here, even though these zeros are after the decimal, what does this rule say? Zeros before the first non-zero will not be significant. So this, and this, because this is the first non-zero and they are before the non-zero, they are not going to be significant. Same thing over here, this 0 and this 0 are before this 2, so they will not be significant, but this 0 is after the non-zero and also after the decimal, so that is why it will be significant. Is this clear? Okay. So if you want, I will make this rule more elaborate. So the zeros after the decimal and the non-zeros are only going to be significant. So that 0 should be after the decimal and also non-zero. There is no non-zero number before it. So not significant. As you can see over here, this 0, this 0, this 0, this 0, even though they are after the decimals, they are before the first non-zero number. So that is why insignificant. But these two zeros, 100%, they are after the decimal and after the first non-zero. So they will become significant. even this 0 will become significant because it is after the decimal and after the non-zero digits. Is this clear? So now if you count it over here, 1, 2, 3, 4, 5, 6, 6 figures, here 3 figures, here 1, 2, 3, 4, 5, 6, 7 figures, 1, 2, 3, 4, 5, 5 significant figures, here exactly 1 significant figure, here 4 significant figures, 1, 2, 3, 4, 5, 6, 6 significant figures, 1, 2, 3, 4, 5, 6, 7, 7 significant figures. So this is how you can measure the significant figures. After this, you cannot be confused. Have I explained you properly now? All the rules? Yeah. So first rule, any non-zero and trapped zeros are always significant. Next rule, the ending zeros and before zeros for without decimals, ignore it. Even the powers of 10, ignore it. The third rule, if there are zeros after the decimal and after the non-zeros, count it like this one or even this one. But before zeros, before the non-zero, never ever count it. That's it. That's the simple way of looking at it. Okay. Now that you have learned the rules of significant figures, let's learn rounding of significant figures, and then we'll see how to use it in calculation purposes also. Very, very important, guys. Yeah, rules of rounding off. Now, this is very, very important, guys. Observe this carefully. Say, for example, you have a number like, let's say, 73.27, okay, or let's say 73.28. Then you have a number like 73.22, or let's say 24. Then you have 73.25, and then you have 74.25. All these numbers have two decimal places. I want to remove the two decimals and write it into single decimal. Sometimes you have to round off to one decimal, or you are getting 5, 6 places, you want to get it to one decimal or two decimal places. So how do we round it off? So always, whichever digit you want to eliminate, let's have a look at it first. The digits that I want to look and eliminate, these are the digits. Let me just block it over here. I want to get rid of this, 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 and this. I want to get rid of it. Now, whichever digit you want to remove, I want to remove this digit. Check whether it is more than 5, less than 5, or equal to 5. Like in this case, it is more than 5. In this case, it is less than 5. Here, it is equal to 5. And let's say, I think I had to use some other thing. 74 point, let's say, 35 chumma I have taken, or let's say, maybe 15 chumma I have taken it like this. Okay. All right. And this number is also equal to 5. Now observe the rule. If it is more than 5, then go to the previous digit. Yes, go to the previous digit if it is more than 5 and add 1 to it. Add how much to it? 1 to it. And then write down the number as it is. So this will be 73.2 plus 1 is 3. That's it. That is the answer to single decimal place. If it is more than 5, add 1 to the previous digit. Here, if it is less than 5, don't do anything. Just carry that digit as it is. Just carry that digit as it is. Don't do anything to it. So this will be 73.2 only. It kind of makes sense. 73.28. 28 is closer to 30. So that's why when you round it off, 0.28 will become 0.3. 0.24 is closer to 20 than 24 is closer to 20 than 30. So it will become 0.20 or 0.2 basically. Makes sense. But here comes the problem, because 0.25 is closer to 25, is closer to 30 also, 20 also. Which number do I choose? 30 or 20. Always make it even. That's the rule. So this case, 2 is basically an even digit. The moment it is even, just write it down as it is. Don't change anything. So this will be 73.2 because 25 is closer to 20 and 30. 20 is an even number, 30, that 3 is an odd number. Not, don't take 20 and 30, that 2 and 3. 2 is even, 3 is odd. So always make it even. Here, when you look at 15, 15 is closer to 10 also, 20 also. Look at the previous digit, it is odd. The moment it is odd, add 1 to it. Add 1 to it to make it even. So that's it. This will become 74.2. 74.2. Is this absolutely clear how to do it? Very, very simple. Okay. So if it is 0.5 only, the main problem comes, then you just try to make the previous digit even. That's all you are trying to make it. Okay, sir, I understood, sir. Sir, but what if it is from 3-4 decimal places to 1 decimal or 2 decimal place? Like for example, 1.2693, then let's say 1.26, or let's say 2641, 1.2650, 1.2750. I want to eliminate these 4 decimal places and convert it into 2 decimal places. So first let me block those digits which I want to get rid of. I want to get rid of 93, I want to get rid of 41, I want to get rid of 50, and over here 50. These are the digits which I want to get rid of. I want to get rid of these digits. Now, here is the challenge. When you want to get rid of one digit, you are comparing it with the number 5. Now think logically. If you want to get rid of 2 digits, will you still compare it with 5? Because a 2-digit number will be always more than 5. No, you will compare it with the number 50. Yes, here you are comparing it with 5. Here you will compare it with 50. 93 is more than 50. 41 is less than 50. 50 is equal to 50. 50 is equal to 50. That's what it is. Now go to the previous digit. Exactly the previous digit, not 2 digits, just the previous digit. It is more than 50, means you add 1 to it. If it is less than 50, don't do anything to it. If it is equal to 50, check the previous digit. Yes, it is even. Then don't touch it. Just take it as it is. If it is odd, then make it even by adding 1 to the previous digit. That's the logic. So this will become, because I've added 1, so this will become 1.27. This will become 1.26. This will become 1.26. Again, even means just as it is. If it is odd, just add 1 to the previous digit. So it will become 1.28. That's how to do the rounding off. Is this clear? Perfecto. How many of you did not know this? How to get rid of 2 digits or 3 digits? So can you guys quickly tell me, how will I round off 35.2689 to 1 decimal place? To 1 decimal place, not 2 decimal place, 1 decimal place. 1.02058 to 1 decimal place. To 1 decimal place. Okay. And then 2.68368, or let's say 6850 to again 1 decimal place. Everything to 1 decimal place, guys. Everything to 1 decimal place. So first, block off the digits that I want to get eliminated. I want to get rid of this. I want to get rid of this. Here I want to get rid of this. Okay. When it is a 3-digit number, I will compare it with 500. 689 is more than 500. 2058 with a 4-digit number, that means it is less than 5000. 850, 3-digit number, that means it is more than 500. That's it. Okay. If it is more than 500, go to the previous digit, add 1 to it. Add 1 to it. Here, less than 5000, just copy paste the previous digit, don't touch it. More than 500, then take the previous digit, add 1 to it. That's the logic. So this answer will be 35 point. Adding 1 to 2 will make it 3. Carrying forward as it will become 1.0. Here, this will become 2.7. Is this clear? That's how you round it off. Very nice. Many of you got it. Proud of you guys. Amazing. Very cool. Very cool. If you guys got it right, and if you know what to compare it with, that's it. Your job is done. Everything is done to a single decimal place. You just need to know which digits you want to get rid of and compare it with a suitable power of 5, 550, 500, 5000, 50,000, whatever it is. Is that right? Very good. 35.3, 1.0 and 2.7. Excellent. Really proud of you, my future doctors. Perfecto, my dear NEET warriors. Now, when you want to calculate it, what you will do? Observe. When you want to do calculations, for example, whenever you want to do addition and subtraction, then how will you take care of the decimal places? Versus when you have multiplication and division. Multiplication and division versus multiplication and division. So let's take examples of this so that you guys get an idea. Let's say you have 29.02 plus 5.00 or 5.016. I want to find that. Or let's say 1.0006 plus or 1.0036 plus 7.1234. Chumma some random example. 1, 2, 3, 4. No, let's say 1, 4, 3. Okay. Let's say 1, 4, 7. Okay. Or maybe 1, 4, 8. Chumma, I've taken something. Then what will you do? Versus 98.70 minus 2.0 or 2.1000. What will you do in this case? Okay. So these are all additions and subtractions, like you can see. So whenever you have addition and subtraction, the rule is the final answer should have the least of the decimal places. Least of the decimal places. Very, very important. Least of the decimal places. Read it again and again. Here, if you notice, we have 1, 2 decimal place. Here we have 1, 2, 3 decimal places. So 2 decimal places is basically the least of the 2 numbers being added. So just do the normal addition like you would do, which is not going to be the final answer yet. So let me just do the normal addition. So this will be 6 plus 0 is 6, 2 plus 1 is 3, 0 plus 0 is 0, decimal as it is, 9 plus 5, which is 14. So 1 carried over. So 34.036. Now the logic is the final answer should contain the least of the decimal places. That means I need to get rid of this number 6. I need to get rid of this number 6 because it is 3 decimal places now. If you compare the number 6, it is definitely more than 5. So if it is more than 5, what will you do? Go to the previous digit and you are going to add 1 to it. So the moment you add 1 to it, you are going to get the final answer. So this will be 34.0. 3 plus 1 is 4. So 34.04 is the right answer. 34.04 is our final answer. Is this clear? We have rounded it off because we can't have 3 decimal places. Least of the 2. Okay, let's do this. Let's do this. What do we get? 6 plus 0 is 6. 3 plus 8, right? That's going to be 11. So that 1 carries forward and it becomes 5. And this is 1. And this is just going to be 8. I will now count the decimal places. 1, 2, 3, 4. 1, 2, 3. So 3 decimal place is basically the least. So I can't have 4. I need to have 3. So I need to get rid of something. I can see I have to get rid of the number. Coincidentally, it is 6 only. No issues. So 6 is more than 5. So if it is more than 5, the previous digit, I should add 1 to it. And then it will be the right answer. So it will become 1 plus 1 is basically 2. This will be 5. This will be 1. This will be 8. 8.152. That is the right answer while adding. Last question over here. Well, just imagine 0 and 0. These zeros were not there technically. Just chumma I have put it for subtraction because sometimes you might need to carry forward. But in this case, I don't think you will need. So 0 minus 0, 0, 0 minus 0, 0, 0 minus 0, 0, 7 minus 1, 6, 0.8 minus 2, 6. Why am I getting 6 every time? 9 minus 0 is 9. Okay, 96.6000. Okay, but as you can see, this number had 2 decimals, this number had 4. So 2 decimal places in this case is basically the least. So final answer should also have 2 decimal places. As you can see, we can just get rid of these zeros. You don't have to do anything technically. You can just write it down as 96.60. 96.60. That's it. That is the answer. Okay. I have also seen sometimes some questions regarding who is more accurate. Like for example, 5 versus 5.00 versus 5 into 10 to the power, or let's say 5.0000. No need of 5 into 10 to the power, just this. Who is more accurate? Who is like having less error? As you can see, 5 is same in value as 5.00, same in value as 5.000. But understand, because I have gone to more decimal places, that means I have taken the pain, I have taken the effort to find out what is the value till this place. After this is questionable. After this, I do not know what might come. It could be any number like 5, 6, 7, 8, 9, 10, anything. Here, I have calculated only till 2 decimal places. Here, I don't know only what will come after the decimal place. So 100%, this is the most accurate. This is the most accurate, precise measurement. This is least precise or least accurate measurement. Is that absolutely clear? Why this is less accurate versus this is more accurate? Because I have taken more effort to calculate till more decimal places. Making sense? Okay, sir. So this kind of thing might also come. Now let's go to multiplication and division. What happens when you multiply and divide? Let's say how to multiply 72, or let's say 1.500 multiplied by 3.0. Okay, or you have to multiply 45 multiplied by 45.000 multiplied by, let's say, 3. Okay, multiplied by just the number 3. Okay, fair enough. Or let's say you have to divide 75. You have to divide it 75.0. You have to divide it by, or let's say 750.0. You have to divide it by, let's say, 3.0. Okay, let's see what do we do in this case. Okay, 3.0, or let's say something like this. Whenever there is multiplication or division, the final answer has the least of significant figures. Least of significant figures. This is very, very important. Least of the significant figures. For addition, subtraction, it is least of decimal place. They are two different things. Just do the normal multiplication first. Don't bother so much. Or division, whatever it is. 1.5 into 3, guys, 15 3 is a 45, right? So it is just going to be 4.5. So just put 4.5 as of now. Don't touch anything more. Okay. Here, 45 into 3, that's going to be 135. Just leave it as it is. 750 divided by 3 is going to be 250 numerically, but these are not the final answers, mind it. These are not the final answers. These are just value-based multiplications or divisions. Now count the significant figures in each one. 1, 5, these zeros are significant. This significant. So the least is 2. So 2 is basically the least significant figure here. Here 1, 2, 3, 4, 5. Here only 1. So this has one significant figure, which is basically the least of the two numbers. Here 1, 2, 3, 4. Here 1, 2. So the least significant figure is two significant figures. Two significant figures are the least. So final answer should also have, that many significant figures. Here you should have two significant figures. So 4.5. Oh, already it has two significant figures. Hence, the final answer is simply put 4.5. But by chance, example, there was a 0 here. Then you should deliberately add one more 0 so that three significant figures are there, because then 3 will be the bare minimum. Is that clear? So for now, 4.5 is the right answer. Don't have to worry. One significant figure. Oh my God. So first of all, let me write it down like this. 1.35 multiplied by 10 to the power 2 before I get rid of some digits. I want only one significant figure, meaning I need to just get rid of the number 35. I don't need it. Powers of 10 are anyways not significant. And this number 35 is less than 50. If it is less than 50, the previous digit should just go as it is. Don't have to touch it at all. Hence, the answer will be 1 point. These have gone off into 10 to the power 2, which is the same as writing 100. So the answer to this 45 into 3 is 100 with the application of significant figures. Please remember, these zeros are not significant. These powers of 2 are also not significant. Is that right? Powers of 2 are also not significant. So 1 point is the same as writing 1. Okay. So a lot of people get confused. Sir, if I write this 3 point, is it the same as 3? Yes, it is the same as 3 only. Okay. So even if you don't put anything over here, it is understood. It is 3 point, means you have not taken the effort to find the decimal place. So, it is just the same as writing the number 3 only. So this has now been written down with appropriate significant figures. Clear? Okay. Over here, two significant figures only. So 250, can I write it as 25 into 10 to the power 1? Actually speaking, over here, this 0 was anyways not significant. This was also not significant. So either you can write the answer as 250 or 25 into 10 to the power 1 or 2.5 into 10 to the power 2. All these answers are correct, because all the powers of 10 or these zeros in the ending are anyways going to be insignificant. Are anyways going to be insignificant. Is this absolutely clear, my dear students? How to do the calculations part? Very good. Excellent. So let's do some questions. In which of the following numbers all zeros are significant? All the zeros have to be significant. In which of these following numbers? As you can see, any zero before the first non-zero is never significant. This not significant. This is not significant. But only in this case, these zeros become significant. So I think it should be option B. Yeah, B option. Very good. Crystal clear. Awesome. Very good, my dear students. Let's go to the next question coming up on your screen. Here it comes. The diameter of something is measured using some instrument, doesn't matter what it is, vernier, this, that, forget it. The values are 3.33, 3.32, 3.34, 3.33, 3.32. The average diameter, mean means average diameter is how much? How do you find out average? Mean means average, guys. So average diameter will be, simply put, d1 plus d2, like that, d4, the whole thing divided by the number 4. That's it. I think 1, 2, 3, 4. Sorry, there are 5 values over here. So d5, the whole thing divided by 5. How many ever values are there? You divide it by the number of quantities. All right. So let's do that now. So what are the numbers? 3.33, 3.32, 3.34, 3.33 again, 3.32 again. Just do the simple addition and tell me what is it that you are getting after adding all of them. Just add all these things and just tell me what is it that you are getting. 3.33, 3.32, 3.34, 3.33 and 3.32. Just add them. First we are doing the numerator calculation. Just adding all the diameters, then we will divide by 5 later on. Not yet. Just add it and tell me, guys. Quickly. Yes. 3 plus 2, 5. 5 plus 4, 9. 9 plus 3, 12. 12 plus 2, 14. So we should get 4 over here. Okay. And 1. 1 plus 3, 4. 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. 13 plus 3, 16. So 6 over here. Point 1 carried forward. 1, 2, 3, 4, 5, 15 plus 1, 16. So this will be 16.64. Just check this out. 16.64. Everyone is getting 16.64, my dear students. Everybody? Okay. Yes. Very good. Very good. Not 9.4 Go version. Just check it out. It is 16.64 only. Yeah. Just add 3.33 plus your 3.32 plus 3.34 plus 3.33 and 3.32. Just see how much are you getting. 16.64. Yes, very good. Perfect. Okay. Now, the final answer should have the same decimal places as all these. So we are done. Nothing problematic. Now take 16.64 and then divide it with the number 5. Divide it with the number 5. And just see how much answer are you getting. How much answer are you getting? Divide it. Divide it, guys. Divide it by the number 5. Yep. And just see how much are you getting. 3s are 15. 1 6. So decimal 3.3. Okay. 1 4. And then this is 2. 48. Just check this out. 3.328. Are you getting it as 3.328? Okay. So we are getting this answer as 3.328, which is there over here, but don't hurry up and mark answer A because I think you will get negative marks. Because check it, all of them have how many significant figures? How many significant figures, guys? 3 significant figures. Yes, all these numbers have 3 significant figures. or basically 2 decimal places. So the final answer, when you do addition, what should it be, guys? It should also have exactly 2 decimal places. This should not be there. This number 8 should not be there. Compare this number 8 with the number 5. It is more than 5. So the previous digit has to be added by 1. So what will it become, guys? The final answer, it will become 3.33. Hence, the answer will be 3.33, which is option number C, guys. Which is option number C. Everyone, till this point, absolutely clear? Very good. So this is how you are supposed to solve the questions. This is how you are supposed to solve the questions, my dear warriors. So I hope you guys enjoyed today's class. And this was the last question which we had for today. And if you love the way we teach over here at Vedantu, you should definitely check out our amazing Vedantu Learning Center spread across the country with not just amazing teachers, but also amazing use of technology, smart clickers, and recordings of the classes of a physical classroom of a offline. Classroom sizes are very small because we believe in high student teacher ratio. And if you're lucky enough to have one of these Vedantu learning centers spread across, please visit it. But maybe sometimes you are like, no, sir, I am comfortable at home. Then we have the option of an offline like learning experience right at the comfort of your home, which is called as our Vedantu NEET Pro batch, which is available in pure English as well as Hindi English. Up to you. And you get offline like discipline with a mentor, with a student academic mentor, regular parent teachers meet, which happens in offline as well as in online. You have regular class test series, final mock test series, and all India revision test series with final revision leading up to the NEET 2025 exam. So all of this at a very good affordable price because the batches have just started. And if you have not yet enrolled, please check out the description box. The links are there for booking a slot for your, where is it? Yeah, let me just go to the live session. Yeah, for your meeting or for your demo. So you can book your demo right away right now. So if you want the NEET 2027 or 2026 Pro batches, you can book a demo by clicking on this particular link. Just enter your details over here. This link will open up. I think internet is slow. And if you are looking for the offline, batches, you can see the offline batch links are also there over here. NEET offline courses. Click on this link. You can select your center and you can definitely join. Right? Thank you so much, guys. Make sure you are liking this video and comment the answer of today's session in the comment box. Okay, I'm going to read out all the names next lecture. Okay, bye bye. Have a great time. All the best. Subscribe and like. All right.